So in this video, I'm going to demonstrate finding the Laplace transform of square wave using waveform synthesis. Consider a square wave of amplitude varying from plus V to minus V. And its duration is, one cycle duration, it is a 2t. So after the 2t, again, it is going to repetitive one. So x-axis is the time and y-axis is its magnitude. So total magnitude of the square wave is 2v. So first, to find the Laplace transform of this square wave, so this is made up of a unit step functions. So first we'll understand the Laplace transform of the unit step function. The unit step function, it is defined as u of t is equal to 0 when t is less than 0 and is equal to 1 when t is greater than 0. And the Laplace transform of this unit step function u of t, it is a 1 by s. And similarly, while finding the Laplace transform of this square wave, we are going to use a delayed version of the unit step function. So for that, we are going to use a time shifting property. So it says that if Laplace transform of f of t is f of s, then for any real number t naught, the Laplace transform of t minus t naught with u of t minus t naught, it will be equal to e to the power of minus t naught s into f of s. So this will be the delayed one. Okay, we are going to make use this property to find the Laplace transform of this waveform. So it is a square wave, and so it is a repetitive one. So we are going to find out the Laplace transform first, okay, for one cycle only. What is the duration of this one cycle? It is of a 2t. So one cycle duration is 2t. If we determine the Laplace transform of this one cycle, then the next one is a repetitive one. So that's why first we will find out the Laplace transform for one cycle. So this will be of a made up of unit step function. It is unit step function. And from 0 to t, its magnitude is v, and t to 2t, its magnitude is minus v. So 0 to t, its magnitude is v, and t to 2t, it is a minus v. Define a unit step function with the magnitude of v, so v into u of t. So when I define like this, its magnitude, okay, it will be go on increasing. So when I define the unit step function, its magnitude will be go on increasing. But in my case, so at period of time, okay, it has to be t to 2t, its magnitude should be minus v. So it is a v, and at this time it is a minus 2v. It starts from t. So that's why I'm going to introduce a unit step function with the magnitude of minus 2. So plus v and minus 2v. So when I'm adding these two, it is of a minus v. And I'm introduce this unit step function at a time t, capital T. So it is of a delayed by a period t, capital T. So minus 2v, its magnitude, and u of t minus t. So I introduce this unit step function at time t. When I'm adding these two, the resultant waveform. So when I'm adding these two, resultant waveform will be, so looks like this. So now when I'm adding at a t, it will go on, okay, at this point it go on increasing. So I'm introducing a minus 2v at a t. When I'm adding at this point, so v and minus 2v. So it will become a minus v. And again, this will be go on continuously. It will be constant with the magnitude of minus v. But in my case, it should come to 0 at 2t. It should come to 0 at 2t. So when adding these two, I'm getting a resultant this waveform. At 2t, it should come to 0. So this at 2t, to bring it to 0, I'm adding a plus v u of t minus 2t. Is this I am introducing at a time period 2t. So v into u of t minus 2t. If I am adding these two, if I am going to adding these two, the resultant will be, so looks like this. So at 2t, so this minus v and plus v will be cancelled out. It becomes a 0. So this will be the overall waveform synthesis of this one cycle square wave. So the first functions I used is a v into u of t, and the second function I used is a minus 2v u of t minus t. The resultant of is this one. And third function, the third unit step function is of a v into u of t minus 2t. So I used 3 unit step function. One is v into u of t, second one is minus 2v into u of t minus t, and third one will be a v into u of t minus 2t. Yeah, total that function is, first one is v u of t and minus 2v u of t minus t, and third one is a v u of t minus 2t. This is introduced at 2t and this is introduced at t. So Laplace transform of this one is u of t, unit step function Laplace transform is 1 by s. Again 2v 1 by s, but it is delayed by a time period of t. So it is introduced at minus t e to the power of minus ts. And this one v into 1 by s, and it is introduced at minus 2t e to the power of minus 2ts. So v by s, so I have taken it common, 1 minus 2 e to the power of minus ts plus e to the power of minus 2ts. It is looks like a minus b whole square. So a is a 1 and b is a e to the power of minus 2ts. So a minus b whole square. This will be of a Laplace transform for one cycle. This is a Laplace transform for a one cycle, but I need a Laplace transform for full waveform. So Laplace transform for complete periodic waveform is 1 divided by e to the power 1 minus e to the power of minus st into f1 of s. In my case, t, the duration of the one cycle is 2t. So 1 minus e to the power of minus s into 2t, where this 2t is duration of the one cycle into, so whatever I have determined the Laplace transform, there is a v by s into 1 minus st whole square. So 1 minus e to the power of minus st whole square and 1 minus e to the power of s minus st whole square. So this one I have written as it is. This is something like a square minus b square. So a plus b into a minus b. A plus b into a minus b. So this is a whole square, and this square and this will be get cancelled out, and the remaining is 1 minus e to the power of minus st divided by 1 plus e to the power of minus st. So this is the Laplace transform of the entire waveform.